Good morning and welcome to the CADclass podcast. I'm Josh,
I'm Jake.
and we're finishing up the book we talked about last week. So this is going to be a nice, quick session. We say quick, but then we'll start talking and rambling, and it'll be half hour or so.
Yeah.
But really quickly, good
It
morning,
always
printed by
ends up
John.
every single time we say, "Oh, yeah, it'll be a quick episode today."
just a couple minutes.
It's a
Yeah.
lie. It's a lie.
Good morning, printed by John, Derry, Ogre, PC Van Vliet. It is wonderful to have you here with us this morning. Tons of stuff coming into the I made a thing, and Jake, tons of stuff coming into the I failed a thing, which I'm
Yeah,
pretty excited about,
I
actually.
I love that. If you guys didn't check it out last week, we made a new room in our Discord server called "I Failed a Thing," purely being born out of I tried to make a project last week, and for the first time in a long time, I failed completely. I completely failed. The file was tricky, the assembly was tricky. Fair enough. I tried it 3 times, and I failed every single time. And it hurts a little bit because I'm like, I'm a maker. I know what to do stuff. I know how to fix stuff, and it just beat my ass, and I couldn't do it. And so we wanted to post a new room where anytime you have failures, something goes wrong, instead of hiding it, show it off. And I got to tell you, it's so cathartic. It's so fantastically feels good to say, I screwed this up. This went wrong. This exploded. This turned into a big pile of spaghetti. And it's been nice. It's been
And
really nice.
I think double click on that for a second, because this, one of the things I think that plagues the online world is this illusion of success at all
Yeah.
places, right? So you see people, very rarely, very
One more time.
rarely.
One more time.
Yeah, I can't speak. Rarely do you see people's failures, and do you hear people talk about what it actually took them to get there? I listen to a lot of podcasts about startups and startup founders and companies and things like that, and they'll often go pretty deep into those failures. But if you were to just look online, you would think that people are just successful right away with 3D printing. You would think their business just worked without any effort. And so, and
Yeah.
the same with like YouTube and influencer culture. You see these people, and it's that's what I really love about it is
Yeah.
no, you're making progress, you're most likely failing at something, and so I love
It's
it.
it's 2 steps forward, 5 steps back, 7 steps forward, 1 step back, 0
Question
steps
your
forward.
question your own existence and whether or not you're an idiot.
Yeah.
Just permanently, like I'm just dumb. That's it. That doesn't get any dumber than me. So
Yeah.
there we go.
So, but it feels good.
I
Josh,
see.
you have been playing around with the drone this week.
I was exactly going to say that. I saw Quad Daddy FPV on here, and that along with Dairy. So I had a fun experience. Jake, when is the last time? I think I know the answer to this. When is the last time you tried to learn something hard and new? And what was it?
Ooh. I tried to make a hot pot last month, and it was disgusting, and I ruined it.
So food. I was thinking.
But
Like
as far as
InDesign.
software goes, I don't know.
Maybe like InDesign was one of the last ones that you had to learn. And do you remember?
That's like
Do you
brand new software.
recall? I remember when you were learning it. We talked quite a bit, and you were like, "Oh, this is so hard, and it's hard for reasons." You basically told me like, "Wow, this is painful to learn this. This hurts. I don't feel good. I'm tired."
Yeah,
And
it's exhausting.
it's exhausting. And one of the things that I want to make sure that we continuously stay on top of is trying to get down to the level of beginner. So this leads me to my story. I pulled this drone out of a box, and it's been sitting on my table. I have the drone, I have the controller, I have the goggles, I've got the battery charger. And I'm looking at this going, what do I do? What do I do? Like, I have a bunch of stuff. I think I don't really understand how to connect the controller to the drone. I don't know how to fly a drone. So for some reason in my head, I was like, oh, I mean, it's just like a thing with a remote. Like how hard could it be? Like that should be pretty straightforward. And this week I signed up for a simulator to learn how to fly the thing. And I couldn't calibrate the controller. I'm like, which side is the throttle and which side is the yaw, and all these words are being thrown at me, and I'm trying to power it on, and I'm trying to understand how to plug the thing in, and it just got me back to this like I'm a complete noob at the world of drones. and I don't know what the heck I'm doing. And learning it has given me fresh eyes for looking at the people in our community learning something new to go, oh my God, like this is probably what it's like to learn CAD. You don't even know what to do. This is probably also what it's like when you get a 3D printer and you're like, how hard can it be? I just press a button.
Yeah.
And it's magically made. And you're like, wow, you're 2 softwares away. And like there's a whole separation between the two of you. So I've now been flying this drone in a simulator for probably 10 hours. And I gotta say, I am bad at flying it. Bad. I'm on like the second series of lessons to learn how to do it, and I'm just no good at all. I start leaning when I'm trying to make the drone go in a direction. I'm just like, and then I'm like, no, Josh, you're only having to use the controller here, and then I'm leaning the other direction, and so
I think that helps.
So shout out to those of you learning something. Those of you who are new to our CAD community, it gets better. It gets more fun. I can see light at the end of the tunnel. I know this will be fun at some point, but right now it is a heck of a lot of work.
Yeah, yeah. And I definitely want to pick it up and learn how to fly drones and do a little bit of
Well, so
cinematography stuff.
I have some advice for you. Buy the controller and start with a drone simulator. Don't even need to have a drone. So I'll just now that I know what the heck I'm doing a little bit, because Jerry's on here, so I had to over the weekend. I'm sending him notes like, Derry, like, what am I doing? He's like, you're in mode. I fly in mode 3. You're flying in mode 2. I'm like, what the heck is mode? What does that even mean, mode? He's like, oh, it's
difference.
It's like similar to an Xbox controller or a typical. I'm like, I haven't gamed in years. Like I don't even like one of the controls basically stays at whatever position up and down that you move it to for the throttle in my case, and the other one automatically springs back. And I'm like, what does what and why? And it turns out you can change what they do, and you can change whether or not one springs back. So it has been completely overwhelming. And I was asking Derry questions this weekend, and I think he must have just been like, what kind of dumb question is that? What kind of moron does it? Like, I was like, what do I do? Like the stupidest questions in the world. I'm like, I got the controller plugged in. Oh, and then I was a whole other fiasco. So I have 18650s. You have to power the remote with 18650 lithium ion batteries. Well, a couple different chemistries, but I have those batteries. I'm like, no problem. I'll pull them out. Mine are completely dead. I had to go through like 15 batteries because I haven't charged them in a long time, and now they've dropped below the voltage, and you can't even charge them. They won't even charge. So I had batteries in the thing. I failed.
You can't recharge the lipos after they go below a certain voltage?
Technically you can, but it requires some kind of special process to do it. It basically kills them. Yeah. So when you get a dead battery cell, like a whole bunch of batteries, and typically 1 or 2 batteries, and there's bad, the rest of them are good. And your ability to use it is like, because they need to charge and discharge evenly amongst all of them.
Yeah.
So it ruins the entire pack, basically.
Damn.
Anyways, we didn't come here to talk about drones, although the inspiration for this is the drone project in week 3. Thankfully, I have not built the drone frame. I have not disassembled the drone I currently have yet. I'm going to try to learn to fly that, and I guarantee you crash it. And then I'm going to come back to show you that all of you that I failed a thing, and hopefully make that fresh frame to make a successful thing. But anyways, very difficult. Very, very difficult.
I totally agree. I don't know how you're doing it, man. It's definitely one of those areas of just a brand new topic, a brand new tool or toy, and then new software, and then remapping your brain to remote. I'm like, glad I'm not doing it. No, I've got no idea what to do for it. So I'm very happy that you're doing it.
Oh, I mean, this is kind of how we work too. Is like you learn something hard and then you teach me, because you now know all the things, right? You and I think both love turning a big muddy process into a series of steps. I certainly love that. Like, no, there's got to be a way to like systematize the thinking for how to go about this. So I'm now in the process of doing that with this project. And okay, step 1, step 2, step 3. By the way, I also found I bought some unnecessary stuff. The remote control serves as a charger. Like, I wouldn't have known that. Anyways, enough about drones. Yeah.
All right.
No, don't worry, Jake. I got you.
Okay. I want to go ahead and show off all the stuff that's been made on our Discord server this week. There we go. I'm going to go from bottom upwards. But Quad Daddy. I saw this come in, but I couldn't.
That's so good.
That's absolutely hilarious. That's so funny.
Look at this bottom one.
A trailer and a speaker. Oh my
box.
god.
Tell me those speakers work. Tell me those speakers work.
That's
That would
so
be
funny.
so absurd. Have you seen the YouTuber that makes the crazy speaker enclosures? What is his name? Keep showing off
The one
stuff,
where it's all
Jake.
3D printed and it's all wavy?
He's the best. He's honestly, he's amazing. Because he just did a new video as well. Okay, keep going. I'm gonna find it. Oh,
That's
Hexibase. Hexibase.
Hexibase,
You guys need to check out Hexibase on YouTube.
Mm-hmm.
He does 3D printed speaker enclosures, and he does in-depth testing on these enclosures, and he manages to make pretty small speakers sound insane. And he does it in
Really
pretty
physics,
complex ways.
just physics.
He's super interesting. Yeah.
Yeah. From Miss Minnick, I needed a balloon
Quad Daddy,
filling
by the way.
aid.
Quad Daddy says, yeah, they work. Those speakers work.
That's amazing.
Amazing.
Also printed 50 balloon holders. Good lord. Yeah, that's one of those really niche, oh my god, I need a fix right now kind of problems that just the ability to make it in CAD in a handful of minutes and then be able to print it really quickly just to solve a hyper niche issue. That's really why I love 3D printing in CAD.
Mm-hmm.
Like having quick, snappy skill sets with CAD to make pretty simple things is just so awesome. I love that stuff.
Amazing. Yeah.
I saw this, but I didn't look into it. I made a small switch to help people with disabilities to save them some money. That's pretty rad.
I wonder. I'm not exactly sure. It looks like a button that does something. I'm not sure exactly.
It looks like an ultrasonic one where you can wave your hand above it. It doesn't look like a press button. Interesting. That's pretty sweet. I do. So my buddy Ed made this little monitor privacy screen. And it is now one of the challenges in our new Fusion Fundamentals book that's probably going to be coming out in a week. But I love this little stuff. This is just so rad. And then ZDP making some little wall hooks. Lovely, nice and simple. Love to see it. I'm pretty sure I'm fairly certain I saw this on the I failed a thing. But we'll look at that.
I think it was on that. I think it must have now succeeded.
Maybe it was. Yeah.
Yeah. I hope this has been upgraded from I failed a thing to I succeeded.
Yeah. And then printed by John, making a little wind turbine thing with 3D printed blades. I still, to this day, have wanted to make like a little series about the incredibly small scale 3D printable renewable energy sources. That's like, it doesn't need to power a car. It doesn't need to power anything gigantic. I just want it to power a 3D printer. Like I want to make like hydroelectric motor that generates just enough power to use like a really super low power basic printer, like a monoprice, and then an air power or hydroelectric or thermal. I want to do that so badly. Unfortunately, I don't live anywhere near a fast enough flowing river, so putting that off to the side. But then actually 3D printing all the blades, that is just so awesome. And then going into the
This is Turth. I want to say that he was in one of our cohorts here in Sacramento. I think.
Oh, really?
I think he was a high school student. Yeah, and now he must be in college. Yeah.
Hey, that's pretty rad. And then going into the I failed a thing, lots and lots and lots of stuff. This made me giggle using I don't know if it's PLA, but it's printed stepper motor bracket. If you don't know, stepper motors are just, all electronic components are just incredibly complicated heaters. That's all they are, really. You can never get away off putting some heat. And so any single time that you've got a stepper motor that is constantly moving back and forthwards thousands and thousands of times, it just generates so much heat and it just melts into your plastic parts. That's absolutely hilarious. Then getting all kinds of warping. And I think it said it was getting a little toasty. I love that. Really simple little brackets in resin. They snap. I have seen so many resin 3D prints in the last month get posts to all these different subreddits about resin printing, and all of them are, I mean, for lack of a better word, exploding in slow motion, where either the pressure inside is cracking or the resin parts are actually giving up and they're popping open, like all of them all at the same time. And I'm like, oh, do resin parts have like a ticking clock before they snap open? I don't know, but it looks pretty damn similar to that. Dairy making some threads. I said they were killing me last night. Yep, those look absolutely tiny, and it makes. I mean, it's not a surprise to anyone that these aren't really working too well. Tiny threads just don't work with 3D printers. It's just not how it works. There we go. Here is before, and here is after. Yeah, this entire room is just, it's so cathartic. It's actually quite nice. And then John Naratu fan making this gigantic our gigantic geocache, but then it fails halfway up. That sucks.
Is that what happened there? It did fail halfway up?
I think so. That looks like the bottom of it. And then he's not showing us the very top. Or potentially it doesn't screw together.
Yeah.
That happens. Printing 230 degrees. That looks like PETG. And it's all just globbing together. That looks like high humidity. Joshua working on scaling up a motor design. Keep messing up all the hole diameters. Reprinting parts over and over, like twice, I think is pretty normal. That's fine.
Yeah.
But printing it 4 times and it still doesn't work. That stinks. If you're ever making lots and lots of parts that you know have to be pretty exact hole size, I've just made so many jigs where I've 3D printed all of them, like every single different hole in an increment that just increase in size or decrease, and printing it on the exact same printer and going, okay, I know that if I say it's a 1 millimeter hole in Fusion, it's actually going to be 0.9 millimeter or 1.2 millimeter, and that will fit this hole perfectly. So if you make a little jig, it just saves you a ton of time with all this stuff. And then I didn't see this morning. Took a gamble on very low support, and it failed. Yeah, yeah.
That's
Actually,
a big part too.
I actually disagree that it's the low part, because it's actually, I don't know if you guys can see it, but it's actually cracked at the very bottom. And most of the time that happens, it's because the support only has one wall. Go into your slicer right now and increase the wall count from 1 to 2. It increases the time and the material for the support material just a little bit, but it's almost a guarantee that your support material will never crack over and break, which will obviously ruin your project, which blows. But I have seen quite a lot of people just very quickly add super glue to their support material as it's falling. They go, hold. I love to see it. That's awesome.
That's amazing.
So, very, very quickly, for the project this week, we didn't want to do a CAD example, but Josh was going on to this website that I've been on for a billion years because I like nerdy stuff like this, called dimensions.com. If you've never been on dimensions.com, the idea is that they have a repository generally of everything you can imagine, and the whole process is that they will give pretty accurate dimensions, or usually pretty generalist dimensions of everything. So not only the size of your phone, but also buildings, footballs, people, generic sizes of anything, or hyper-specific sizes of things. And it's a really good place to start if you want to get into reverse engineering any products, which is one of the best ways to get a more skill set with CAD. Saying, I have a thing in my hand, how do I can now deconstruct it in my brain of how things go together, but I actually don't know the size, and that is actually really rather critical. And this is the kind of in-between bit. If you can just search anything on dimensions.com, and then try and find something that you know, that you understand how it operates, and then recreating that in CAD is absolutely fantastic. So we have found, I can just share my screen again, or actually Josh found this, I'm not even going to take any. Josh found this giant floor lamp. This, I think we all know this is the the kind of iconic Pixar lamp where it's got a couple different hinges, couple different springs, and this is a pretty simple model as far as its geometry. Obviously, it's got all of its dimensions, but we wanted to challenge you guys instead of just making a single part that's rather complicated, to make a assembly of, well, the entire assembly is complicated, but all of the components are shockingly simple. And it's just kind of going through where you start from and where you finish, how things are actually made. And we want to see just, again, how quickly we can actually make this. Because it seems relatively simple.
Jake, let's double click on that for a second. So you're looking at this right now. Can you talk me through your component strategy? How are you seeing this?
So when I'm looking at all this, I'm looking for mirrored parts. What are they mirrored about? You can see we've got 2 separate angled arms coming up, but there's actually 4 because it's symmetrically mirrored. And so that's kind of making me think that I want to make this, well, symmetrically about maybe the front plane or the right plane, so I can just mirror some parts over. I usually like to start just logically. What is, or the base will actually be the base in real life. I could make this base down at the very, very bottom basically anywhere. But I could also make the lamp. That's obviously a revolved part. But I could make this anywhere. But it would probably be easier to do it at the, at the origin. But it's, even though that would be easier, it's oftentimes easier logically to start at the base, literally, and build off of it. And so I'm going to be starting, grabbing at the bottom point, building off these arms, adding all these joints, and then literally building it piece by piece by piece. Some of them is going to be pretty easy to build in place, and some of them are going to be a pain in the ass to build in place. For example, if you look in the drawings on the left-hand side, this horizontal line, I can just make that horizontally. Very, very, very easily. I can actually make all of the arms in the exact same sketch and then just extrude them as new components. That's really easy. But making the lamp, that revolved lamp in one place, that's a little tricky. In that case, it actually makes more sense to make it as a separate entity, way off outside of the sketch, revolve it, and then use the joint tool to bring it back into place. So there's a bunch of different ways to do it, but I'm just going to be making it as piecemeal as possible. So I'm going to be going back and forth between this and Fusion.
And for those of you who are newer to Fusion, so this is a slightly more complex challenge than the previous weeks,
absolutely,
even though those
absolutely,
are pretty tricky as well. For those of you who are new, pick a part of it. For example, just the lamp head, or just the base, or whatever it is that you think you can accomplish, and build just that. And use that to start to scaffold these skills, right? To start to learn how to do bigger stuff. So even if you aren't able to complete the entire lamp, at least do the lamp part and maybe a cord coming out of the back. And we do have quite a bit of information on joints and assemblies in chapters 4 and 5 now, are they? Or 3 and 4?
Yep. Assemblies and joints.
4 and 5.
Lovely. Okay. Let's get going. I'm going to get started on the base. As you'd imagine, all of these are going to be individual components. Let's go ahead and make a base. I'm going to make a, what am I going to do? Oh, these are on feet. I don't want to make. I'm just going to ignore the feet, if I'm being honest. Make a central rectangle. What is this going to be? 45 centimeters. Ugh. Actually, screw that. I'm just going to make the entire thing in inches. That's just going to make my life so much easier.
Because all the dimensions are in inches.
All the dimensions are in inches. It's just going to make life so much easier.
Yep.
For anyone who doesn't know, you can also type in if your default parameters or default units are in inches, but you're designing in millimeters, you can just type IN after any of your dimensions, and it will do the conversion for you, which is always really nice. This is a gigantic one, 17.1. Adding on a little equal constraint. Lovely. And then extruding this up. Nobody knows. The entire thing's 4 inches. Let's just say 2 inches upwards. And then I'm going to make a similar thing on top. Like we said, not all the dimensions are actually there. So there's really no need, to make it absolutely, on the dot. I'm fluffing quite a lot of this. And
I
that's
was
okay.
hoping for a little bit more creativity in this one as well. So in the previous weeks, it was
Yeah,
number of
yeah.
steps and how quick can you do it, and this time I want to see how you do it. How did you approach modeling this? And then
Hmm.
make it look interesting, change it up a little bit.
Mhm. Oh, this is funky. Oh, that's set to variable. Whoops. There we go. That's why. 0.25. No, let's bump it up. 0.5. Lovely. There we go. This is just really, really quickly. Do you guys see my corners right here and how they look a little bit more interesting than normal? That is because I have added in what's called a setback fillet. Anytime you're adding a fillet on a corner, it's a little bit easier to, or it always prints a little bit better and it looks a little bit better. Instead of just having an equal, what's called a rolling ball fillet, this is called a setback fillet, and it just looks that little bit better. That's essentially this component is all done, so I'm just going to go ahead and activate this top part. I don't know why, but I can't see my timeline at the very bottom. It's kind of blacked out. That's very strange. Okay, I'm just gonna have to make this all in one go then. Uh,
That's
all
very
right.
strange.
Then I'm gonna very funky. Anyway, um,
There was
I'm
a
gonna
there
call
was
this
let me look that up. There's a somebody asked us about that before.
funky.
It's going.
Um, Next up is this part in the middle that kind of holds up the two angled arms. I'm just gonna call it a clevis. I don't know if there's a proper name for it, where it's essentially two arms that come upwards, and you can have hinges that go through it. No idea what it's called. But let's call it maybe foot tall, potentially. But again, I'm going to make this out of the on the right plane or the left plane. It's the same thing. I'm going to be making a construction line going upwards. Actually, no, it doesn't even need to be a construction line. Excusez-moi. Just needs to be generally some arms coming upwards. But let's go ahead and make that completely vertical. This is going to be 12 inches total. For the length of this arm, we're just going to make it a third of it. So I can click that and then type divide by 3 for a little bit of quick math. I'm probably going to make the width of the arms. Ooh, I don't know. Yeah, maybe 2 inches wide, if that. And that could be 0.5. That looks just fine to me. And then we can go ahead and mirror all of that about that vertical line. Oops. Also need to select there. Lovely, and then join back up at the bottom, just so I have two separate profiles. In case you don't want to click on both profiles at the same time, we can also make that vertical line construction, which makes the entire thing just one profile. Then we can go ahead and extrude this out symmetrically. So I'm going to change the direction to symmetric, and we'll make the total distance 0.5 millimeters. Nope, that's a lie. 2 inches? Yeah, that looks about right. Then we can go ahead and add on some half fillets to either end. The type at the top, I want to make it a full round fillet. So I actually want to click on this top face here. Oh, but that's adding it in the wrong dimension. Interesting. The center face. Ooh, I actually don't know what to do here. Side one and then the other. Wow, this is so much more complicated than it needs to be. I hate it. Let's go back to fillet. Yeah, that's 100 times easier. I think I said it was 1 inch wide. Yeah, let's make it 1 inch. Beautiful, beautiful, beautiful. And then I'm gonna add some holes on the top and bottom. I'm almost positive it's because we're streaming this, and that's why. Of why my timeline
Oh,
has
yeah.
disappeared.
But you can't see it in Fusion.
No, no, no. It's just a black bar. I
Hmm.
was working on Fusion literally last night, and I haven't updated it, but I'm like 90% positive that's why. That arm is coming down, but these springs are absolutely very annoying, and they're right in the way. So let's pull this down a little bit. Come on. There we go. Good lad. Let's add some dimensions in between these 2 points. 6 inches. Yeah, that's fine. And then I'm going to go ahead and extrude cut this through the entire thing. Fantastic. Okay. So now I essentially have this very, very simple clevis. And these two pieces are not joined. The bottom piece is anchored. It's grounded. That's why there's an anchor icon in the browser. But this top one is completely unmovable. So I'm just going to add a very simple rigid as-built joint to connect those two. And now both of them are locked together. Now I want to make the new component. I'm just going to call it arms. And this is going to be the really complicated one. I need to make sure all of the individual arms are components, not bodies. But I want to make all of them in the exact same sketch. So this is where it becomes a little bit more interesting, because there's really only there's two arms on either side there with a gap in the middle. So I essentially need to third it. So there's only one line in the middle. Damn, I wish I would have made the clevis gap much like a uniform width. It's 2 inches. Ugh, that's a really ugly fraction then. It's 0.6. Ugh. Okay. That's fine. That's fine. That's fine. Let's make a new sketch on the front plane. I'm going to make a very, very long, skinny slot. That top one, its endpoint doesn't actually end up there. It's off kiltered. But I want to make sure this center line goes through there, but there's no dot in the middle. Therefore, I need to project both these circles that will add the center point that we can then cling onto. Lovely. I'm just going to set a nominal thickness of 1 inch. Oh, thank you, Fusion. Really appreciate that. There we go. No, it's pulling the wrong direction. Come on. Thank you. Yeah, I'll do that last. Whatever. Okay. And then I need to make another slot. Starts at that point and then extends outwards. But I essentially do I need them to be parallel to each other?
Yeah, I think so.
Yes. Yeah. Okay, so let's add on some parallel constraints. I'm going to make some equal constraints to all of these as well. And let's define that. So let's see if it'll let me. There we go. Do these end up? Yeah, so their endpoints are actually horizontal to each other, which is always a little bit funky, but that's okay. Because then I'm going to add another center slot coming outwards. I really don't know how long this needs to be, but I want to make sure that the center point. The what?
We can guess.
We can guess. Does it look like, or does it sound like I know what I'm doing? I don't.
No.
Oh, good. Okay. So this is actually really, really handy by making the mechanics of the geometry in a sketch. The constraints almost act like joints, so I can kind of get a preview of what the motions will look like. Even if I don't use all of the geometry, that's still fairly handy. And so I just like to add all these joints regardless of what it looks like.
Add all these joints?
Add all the what?
You said add all these joints regardless of what it looks like? You mean constraints?
Sorry, add all the all the constraints and all the geometry, I guess.
Geometry.
Is the way to put it.
Yeah.
I think that looks pretty good to me. I don't really need to add in any holes on these ends because I'm just going to be joining to the arcs. So that's completely fine. But then let's go ahead and try and extrude this center one. That's going to be the easiest one to do. I'm going to make it symmetric to a full distance of 2 divided by 3. Now we're thinking with our noodle. This wants to be a new component. The operation is set to new component, not new body. That makes the arms a subassembly. There we go. And I'm just going to rename this top one to be top. Oh, but then I can't see my sketches. No. I'm going to exit full screen. What the hell? It's now a black bar on it. That blows. Okay. I'm just going to have to figure this out as I go then. Yep, because the sketches is inside. There we go. Okay. Oh, that's really funky. But that's okay. And then I'm going to extrude the other profiles. The top and the bottom. These can both actually... Ooh. No, these can't be two bodies. These have to be individual components because they both have joints on the ends of them. Okay. I actually quite like this challenge.
Nice.
It's making me think.
I was gonna say, I might have picked something a little too complex. We'll see. Simplify. If you need to simplify this, make it even simpler.
Yes. This is actually going to be showing off a really good tool. So currently my sketch is in the middle of that top arm, but I actually need it to start on the front face. So I'm going to go into start, and I'm going to select object. I'm just going to click on that front face. So that's where the sketch is starting, and then it just needs to extend outwards. And I'm going to set -2 divided by 3 again. Perfect. Oh, whoops.
Really
I
handy.
accidentally made a new body. Control Z. Let me try that again. Not the new sketch. Oh, come on. God, I don't know why my timeline has disappeared. That is such a pain. I need to do that bit, hide the top section, click that. I can turn it back on. That's fine. I want to start on the front face of that, and it's going to come out -2 divided by 3. I need to set this as a new component. Lovely. Okay. And then I essentially need to do the same thing for that other section. Like that. Hide there. Doobie-doo. I want to make sure it starts at that front section. This is really the hardest bit. As soon as I have all of my sections, then it's pretty easy, actually, to add in. Oh, bugger. I did it again. Did I just say this was the easiest bit or the hardest bit? This is just the most annoying bit.
Well, I mean, it's hard to talk on stream and click the right button. That makes sense. It makes sense. But it is kind of nice, right? Because also to bring it back full circle to the beginning of the pod, when you watch the videos that we produce, you see only the success. You do not get to see all of this little stuff where we may have made mistakes and had to redo it and change the directions and edit, right? And so, so yeah, I like this because in some ways you're seeing the real process. This is how it goes.
You're seeing all of the problems that goes into this. One thing I will note, so I can add a revolute joint between this left angled arm and this top arm because they both share the same arc, but there's no center point over here. So I actually need to add a hole on this top section right here, if that makes sense.
Mm-hmm.
I'm going to make it on that face, and I'm actually going to be projecting the center of this. I do not care how big this hole is. We're just going to make it 0.5 for no reason in specific. But let me hide that second component. The only thing that I care about is actually getting that circular edge that I can snap onto. That's the only thing I really care about. But then I'm going to be... Ooh! Can I use duplicate with joints? I don't know. Obviously, they're already built, or they're already in the correct location. So I'm going to be using an as-built joint. This is going to be set to revolute. Oh, perfect. All right. Everything's fine. Everything's fine. I'm snapping around that portion. Yep. Similar thing. It's already set to revolute because I already changed it. Perfect. That's locked in place. Go up to the top. It's like these two edges. It's the snapping point is about that arc. Lovely. And then finally the revolute on either side, but it's snapping to that hole. Again, the snapping point doesn't matter where it is as long as the circle or cylindrical face shares that edge. That's all we really care about. And now, there we go. Oh, that's weird. There we go. But now as I move this bottom section, then that lamp is moving exactly as it should. Except when it snaps over, then it totally fails. I'm just going to say that this arm right here, this is the action arm, if that makes sense. And so it's actually this joint right here that I want to add on some limits just so it doesn't break. So I'm going to, let's go ahead and open up joints. Is that joint right there? So I'm just going to add on some limits. So let's say the maximum and minimum. So I can actually move these two angled flags down here. I don't know when it fails. I'm just going -15 to +15. Yeah, maybe.
Yeah, that's fine.
Yeah, let's try that. And then that'll figure itself out. Yep, so that's going to give me a top and a bottom, and it still hasn't broken my sketch, which is actually all I care about. This is just a model, and that looks all right. That looks fine. But then I do need to mirror these 2 angled arms onto the other side. So I'm going to try and mirror. Yeah, capture that position. I'm going to try and mirror the components. No, that's a lie. I want to try and. I'm going to try and duplicate this component. Yep, that's fine. Over to the other side, but it probably won't work. Will it? No, it won't work. Clear selection. Oh, did that? Oh, just close it down. Yeah, no, that's going to be a pain because they are the same parts, but they're on different. They're on different faces of the same part, so it's actually going to be a million times easier to just mirror over some components about that front plane. That's just going to make life so much easier, and then I can just very quickly. Oh, so the easy route, or the more difficult route, would be to add revolute joints for the new parts again. But I wonder if I can just add on rigid joints between the 2 sides, or between the 2 copies. Let's try that, because then that's dead easy. When one moves, the other one moves as well. Yes, that totally works. That just joins the 2 parts together. So I don't need to go through and click on all these snapping points, because as you can see, that hole that we had in the middle is now hidden. So it's now totally a pain to work with. So just mirror and then add rigid joints between the 2 identical parts. That make life so much easier. Lovely. What time are we at, Josh?
10, 11. 10, 12.
11. All right. I'm going to make the 2 kind of cross brace arms on either side. If I can zoom over to the model. Yeah, so it kind of needs to come out. It's a bit of a claw, or a bit of a clevis as well. So let's try that out. I'm going to activate this top arm. And I'm going to make a new sketch on the top of it. Yeah, capture that position, because I do not care if it's at an angle or not. I really don't care. But I'm just going to be making a mirror line down the middle. Lovely. I'm actually going to make this a center line because I'm feeling fancy. And then we're going to make a fit point spline. Yeah, let's try that out. Let's see if we can get some interesting arcs going on here. Yes, there we go. That's what I'm looking for. Okay. And then I just want to extend out horizontal, and then I can make those 2 edges tangents to each other. I could have done this with arcs and make it really perfect, but I don't care. It's not the point of this program. I actually want this vertex to be... Oh, it's grabbing onto that point. Yeah, let's delete that. I want to add some tangency to both ends of this spline. And if it's not exactly perfect, that's fine. It's all an artistic project. And then I can actually offset this 0.5 inches inwards. Join up on both ends. And then do I want to mirror it? I kind of do. About that solid line. Oh, it's already done it. Fantastic. Then I can finish this, extrude downwards, but downwards doesn't mean anything because we're off at a different kilter. Negative, what did I say? 1 inch? Negative 1 inch. It's going to cut. Join it. Beautiful. All right. Then we can add on some fillets to knock down these sharp corners. Again, you can add on a full dome to this, but it's a little bit unnecessary, really. And then we can add on some holes. No, I actually don't care. I'm going to activate this top section and then add on our bulb. Bulb? No, what is it called?
Yeah, your lamp.
Shape? Yeah. Well, the entire thing is the lamp. Lamp shade? What? What the hell is it called? Bulb. I'm just going to call it bulb. I know it's wrong. I don't really care. Here's the important bit. We sketched and made all the other parts in the correct final location, but I'm not going to do that for the bulb because the center of axis is going to be a little bit of a pain, and this is just an artistic project. So I'm going to be making a center line, but I don't really care about where this lives. So I'm just going to go ahead and fix this center line just so it's kind of floating in midair. We can make a spline. The fewer the amount of points that you have on your spline, the better. It is just kind of a truth of the universe. The more parts, or the more sections that you have on your spline, the more of a pain in the ass it is to actually get it to
Truth
work.
of the universe.
It's kind of
It's right up there with Newton's law, and
I'm sure it's written down in the Bible somewhere, to be honest. It's like, don't make too many spline points. It doesn't make it more accurate. It just ruins everything. Oh, okay. All right, good. Gonna offset this. When you see the preview, it's actually highlighting my vertical construction line. That's because chain selection is turned on. I just want to turn it off a little bit. Say negative 0.125. That's good enough. And then we can finish off the profile. Anytime you see white dots in your sketch, it means it is not connected. As soon as you do connect it, then we have a full profile. Beautiful. I'm going to be revolving this around the top axis. That looks lovely. Again, I did not measure at all. It looks like I got it pretty close, but I actually don't care. The width of this doesn't line up with the width of the lamp. I don't care at all. I'm just roughing it. So I think we said 0.5 for all the holes. Roughly in the middle. Let me go ahead and show that first sketch just so I can add on some coincident. Okay, here's the thing. I have been saying coincident literally my entire life with CAD. And the word is coincident, but you can also say coincident as well. So I've said both of them back and forth, and nobody's really stopped me. And now I can't remember which one is the proper way or the correct way or whatever. I have no idea which one is which. So if anyone knows, tell me, please, for the love of God, because I feel like I've been making a fool of myself all this time.
I believe it's coincident, but I guess that would depend on where you are as well. I don't know if
I guess, yeah.
if maybe it's different elsewhere.
That doesn't look. That's not right. What? Yeah, you change that around. There we go. Center of that. Move it over. What? Not yet. No, not really. Not actually. Okay. Oh, okay. So funky thing, because the edges of these holes are not flat. They're obviously curved. I can't just click on the edge. I need to click on the inner cylindrical face. There we go. And then I'm going to get a top view, and I'm going to... Oh, damn, I got it really close.
Yeah.
Look at me. I'm just going to use the offset tool to get it about equal, but there's no need to make it perfect. All right, I think that's pretty done for me, man.
It's nicely done. Nicely done.
God, that was tricky without the timeline. That was really annoying.
Yeah.
So for everyone who, obviously can see that big black bar at the very bottom, I'm like 90% sure it's because we're streaming. But I can actually click on my timeline, but it's not showing it. Sometimes when you're importing an STL, your timeline actually does disappear. And that's when you can right click this and you want to say, usually it says capture design history. Currently, I do have a timeline, even though I can't see it. So if I want to get rid of my timeline, then you want to click do not capture design history. Sometimes when you import an STL, your timeline disappears, and then you have to right click the root component and say show or capture design history, and then that will pull the timeline back up. That's one of those facts that like I rarely get to show off because it only happens during calamities. Where'd it go? All that stuff.
All right, so wrapping it up, the challenge this week is to create that lamp, dimensions.com. You can make it an artistic project. Bonus points if you use joints and components, and I would just love to see what you guys come up with. So slightly different from the design challenges of the last few weeks, where it was the quickness or the speed or number of steps was yeah. So this time let's let those creative juices flow. I want to see.
Actually, do you know what I want to see? I want to see you guys recreate an interesting lamp in your house. Get your ruler, get your tape measure, get your calipers, and try and recreate it as best as you can. And the more appearances or physical materials, or the more accurate that it looks, the more points you get. fair and square.
That's it. Jake, I think that's the pod.
That's it.
All right. This has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we'll see you next week.
See you guys.